We look here at the what is known as the Jones oxidation. Jones oxidation is credited to Jones from around the mid 1940s. And the overall purpose of this reaction is it's an oxidation and it allows us to convert alcohols into carbonyls. But the Jones reagent does some things that are very different from a lot of other common alcohol oxidants. So of course, as with any alcohol oxidant, tertiary alcohols don't work. They can't be oxidized. They don't have hydrogens to remove at the carbon containing the alcohol. But with the Jones oxidation, we get a pretty big difference based on whether we use a primary or a secondary alcohol. So in the case of a primary alcohol gets oxidized first to the aldehyde, but that oxidation doesn't stop there. It gets oxidized further to the carboxylic acid. However, a secondary alcohol gets oxidized only once and forms the ketone. So how does this reaction work mechanistically, and why is it that a primary alcohol gets oxidized twice and a secondary alcohol only undergoes a single oxidation? So let's look at our mechanism for this reaction. So the Jones oxidation uses a reagent that's become known as Jones reagent. Jones reagent comes from a mixture of chromium trioxide and concentrated sulfuric acid in water, and that results in the formation of the reagent that we'll see doing the oxidation, which is this one here. So in this reaction, we start with the alcohol pulling a proton off the chromium reagent, and that shifts the electrons onto oxygen. Also, we can note in this reaction that the chromium that we're starting with is chromium 6. And I just mentioned that because we call this an oxidation reaction, but of course any oxidation is always accompanied by a reduction. We call it an oxidation because typically we're only interested in the organic molecules, and the organic molecule is what gets oxidized. But in order of completeness, I will show you here where those electrons are going. So what's getting reduced. All right, but the result from this first step is that we've converted that OH group into a good leaving group, and then we've made an anion of our chromium reagent. And that anion can add in and kick out water. So that leads us to this intermediate. And from here, water comes in, removes the adjacent hydrogen. Those electrons shift down, form the carbon-oxygen double bond, and kick out the chromium group. And so as a result, we form an aldehyde, and then the leftover chromium forms this reagent, which now is chromium 4. So the carbon that was the alcohol has been oxidized by 2 electrons. The chromium is what gets reduced. Now, it might seem like we're done. And had we started with a secondary alcohol, we would be done. But carbonyls in the presence of strong acid, and we'll show this for a secondary as well, which got oxidized to a ketone. Under strong acid in the presence of water, will form what's known as a hydrate, which is just an addition of water. Now, if you look at the hydrate that was formed from the aldehyde, you notice there's still a hydrogen there. Because overall, the formation of the hydrate is actually a pretty terrible reaction. It's a completely reversible process, and it very, very strongly, in almost every case, favors the starting material. Unless you can do something with the hydrate. Now, in the secondary alcohol below that got oxidized to the ketone, there's nowhere for this hydrate to go, and so it just goes back to the starting material. Nothing takes place. But the hydrate that forms from the aldehyde, if you look carefully at this, we have an OH again, and we still have a hydrogen. So as long as there's Jones reagent present, this can get oxidized a second time. We won't go through the mechanism here. It's the exact same mechanism, but that aldehyde gets oxidized up to the carboxylic acid. And even though that equilibrium isn't very good for hydrate formation, it's good enough here because any hydrate that does form gets oxidized to the carboxylic acid, and so we take advantage of Le Chatelier's principle that pushes the aldehyde towards the hydrate, and eventually we end up with complete oxidation. So Jones oxidation, the primary alcohol oxidizes twice, we get the carboxylic acid. With a secondary alcohol, oxidizes only once to give us the ketone.